Okay, YouTube, this is going to be a brief video that I'm doing on the abbreviation of the polar form of a complex number. And that is to say that when we're working with complex numbers in polar form, we're always dealing with this r times cosine plus I sine theta because we know that the a value of our point a plus bi. We know that the a value is r cosine of our angle, and we know that the b value is r sine of our angle. Then we could say that really this number right here is just r cosine of theta plus r sine of theta times I, and that's where we're kind of getting this factored out r expression where we have cosine of theta plus, and put the I in front here. That's the I right there. Sorry, a little I right there. I sine of theta. We just list this r out in front. And so what we're going to do is we're going to say that since all polar form numbers are in this form, and really since every complex number in standard form or in polar form, this should say polar form here, every complex number in polar form gives us the value of r and theta, and it's always in this r cosine theta plus I sine theta form. Instead, what we're going to do is we're going to use the following abbreviation as opposed to what we usually use, which is this r cosine theta plus I sine of theta. And so what we're going to say is that r times the cosine of theta plus I sine theta can just be written differently in what we call this here as r cosine I sine of theta. And so you'll notice that I've said that we can read this as r cosine I sine of theta, but we really mean the same thing as this expression on the left. You can just see that it's a lot more convenient because we're representing our r and our theta, okay? And we've also got our cosine, our I, and our sine, even though it's not representing the addition that's going on the inside here. So this r cosine I sine of theta, we could also simply read this as r cis theta, and that's usually what happens here. But you can see that any number in this polar form that's elongated, we could just abbreviate it, and that's going to be a little bit easier for us to work with. Now, with respect to our r cosine I sine of theta, there are a couple things we do want to write here in terms of vocabulary. Now, going forward, we've looked at this r as at least, when we talk about our number in polar form, we could say that r is the distance from our number here in polar form, this r cis theta, and at some direction theta. Instead of now referring to these as like r as a distance and theta is just the angle of rotation, what we're going to do is we're going to give them actual names. So we're going to say r is the modulus of our number, the number, okay? And we're going to say that theta is the argument of our number. So to put this a little bit more succinctly, basically what we're saying is that we're going to refer to our distance from the origin as our modulus. And that direction that we're going in here, we're just going to refer to this as the argument of the number. And so really, in polar form, the two things we're always looking at are the modulus and the argument, which are really just distance and direction. And so looking at these numbers down here, I just really quickly wanted to take them from this elongated, complex number in polar form and put it into this abbreviated form, r cis theta form. So I just want to see how easy this can be here. We can see that it's pretty easy to recognize that our r value here is -5 in this polar form of our number, and that at least our modulus is -5, and we say that our argument here is 120 degrees. So with this modulus and argument here, we could say that in abbreviated form, we would say that this r cis theta form would really be -5 cis 120 degrees. And you can see that this would still tell us the same information that we need to know, which is that we're going to face 120 degree direction and then walk backwards 5 units. So here's our abbreviated form here. When we look at letter Z, just as easily we can see that r is 10. And it looks like our direction or our argument that we're heading in here is 2 pi thirds. So we have our modulus and our argument here. And with these two, we could just say then our complex number in abbreviated form would be 10 units and a 2 pi thirds direction. So we would say that this is 10 cis 2 pi thirds, and that it would represent the same thing as this. Likewise on these last two, I kind of mixed it up a little bit here. We can see that our modulus value here, our distance from the origin, our point is 2.7 units out, and that our argument, the direction that it's heading in, is a 3 pi fourth radian direction. And so we could see that this here, in abbreviated form, Z, is really just 2.7 units cis, and our theta here is 3 pi fourths. So we would read this as 2.7 cis 3 pi fourths, or 2.7 cosine I sine 3 pi fourths. And so this is our polar form number abbreviated. And this last one here, I just want you to see that, even if you have decimals, we could say 21.8 is our r value, and we'd say, what's our argument here? 302.5 degree direction. So, turn to that direction and walk 21.8 units out. We're going to start using this abbreviated form more often, especially when we start multiplying, dividing, and raising to powers these complex numbers that we're working with in polar form. Cheers.